All right, so this is going to be a demo of my stock predictor algorithm. Um, adjusting the exposure on the camera. Yep. So this is the main file. There is import data that just imports the CSV, and then process data that breaks the data down into the multiple time-step windows that is needed for training, as well as providing the output array for training against. And then that's just all the input array and then the output array are returned. So this is the main function. So it inputs the S&P 500 CSV, which I have saved here in the directory. And then it passes it through the process data and then creates windows of 128 trading days each. That data is then ultimately going to be trained, or the model is going to be trained with that data in this main training loop here. So the actual model is instantiated here. So here I actually have a load dictionary, or a state dictionary of the model. So this has the old weights. For the purposes of this, I'm going to comment this out, so that way we're starting fresh with a new model. The optimizer we are using is stochastic gradient descent. That's here. Then the loss is just L1 loss, so that is just your average, or the average absolute loss of the model. So this is the training loop. So the outer for loop here is just the number of epochs, and then this inner training loop is the actual batch training. So this will go through the number of batches. So in this particular set, I have the batch size set to 2,422. So that gives it about 4 batches per epoch. And again, I'll set this lowest loss to a high value, so that way it saves every time it goes down. And here we go. So this is just saving the output if it is low, if the lowest loss is detected, and then at the end it just saves the final. And then here we have the evaluation, so it just sets the network to evaluation mode, so that turns off all the gradient tracking, so speeds things up. And then here we test it against the S&P 500 returns. So this, as it's currently configured, does not allow shorting. If I wanted to allow shorting, I would uncomment this. But for this case, we're going to not allow shorting. So let's go ahead and train it. And actually, just to speed things up, I'm going to set the number of epochs to 3. So even though I am running this on the GPU, it does take some time to execute. So I found with this model, it actually took about 800 epochs before it got to reasonable returns. So you can imagine how long that would take. Here we go. And now I believe it's in the evaluation stage. So this actually executes on the CPU. So yep, the algorithm performance. So it actually just got only a score of 1, which is okay, but that just basically means that it did not actually grow the returns any. And then the market performance is just 24x. So that would be ideally what you would shoot for.